Unit 1, Objective 5, Graphing with Restricted Domain. Now, all that means is we're not going to see the entire graph. We're just going to see part of it. But you need to have an understanding as to what the entire graph would look like. For instance, example A, f of x equals -2. Now, this is just an equation that says f of x equals a constant, and that constant happens to be -2. So, it's just a horizontal line. Now, I'm not going to draw it yet, but it would be a horizontal line going through the value of y equals -2. But there's a little catch on here. The first thing the problem's asking is evaluate the function at x equals 6. Well, when x equals 6, what's the value of y? Well, it's -2. The value of y is -2 at every location of x. Now, what would the graph of f of x be as long as x can't equal 6? Well, when x equals 6, 1, 2, 3, 4, 5, 6, down to -2, we're going to put a hole in this graph right here. And otherwise, we're going to graph the rest of the graph, which would be the horizontal line at -2. So the fact that x cannot equal 6 means we can't use the point 6, -2, but we can use every other point we need. Now, the domain would be -infinity, but we're going to have to jump at the value of x equals 6. So we go +6 with an open, and then we jump it, and we pick it up at the other side, and we go to +infinity. So there's the domain. Now the range. The range usually goes from low to high, except for the fact that there's only one level, and that's -2. So we just say the y value is always -2. All right, the B graph, or the B example. Let f of x equals let f of x equal x. Well, we got to have an idea of what that graph would look like also. F of x equals x, or y equals x, is just a nice diagonal line with a slope of 1 that goes through 0, 0. So when x equals 4, we just plug it in. Okay? The value when x equals 4, the function is at 4. So now graph f of x if x is less than 4. Well, we know 4 would be on the graph, except we can't use x equals 4, so again, it's an open hole. It's not closed. And then the graph, it still has a slope of 1. It's a linear equation with a slope of 1, but it's for all x's that are less than 4. So the only part of the graph we really care about is the part that's doing that. Now, domain and range of that graph. As far as x is concerned, it's going to the left forever and ever, -infinity. But the furthest right x that we're using is 4, and we really aren't even using 4 because it says less than 4. It doesn't say less than or equal to, so we put 4 with an open right there. Now range. It goes down forever, so -infinity. And the highest point, again, is also 4. But again, we really don't use 4. So 4, 4. Okay, the next graph. Let f of x equal x squared. We got a pretty good idea of what that is. That's just a parabola with a vertex right down there at 0, 0. So let's figure out if we evaluated this graph at x equals -1. Just plug in. -1 squared is +1. And what if we also evaluated it at 2? 2 squared is +4. So what would that graph look like between the x values of -1 and +2, but not including -1, but yes, including +2? Well, -1, 1 would be right here, and it would be open. And at the other end of the graph, where x equals 2, 1, 2, 1, 2, 3, 4, remember we said this is a parabola, and the parabola, if you go back to the function y equals x squared, you know the vertex of that is at 0, 0. So the graph in between -1 and +2 would look like it stops right there. It doesn't go any further. So that's what the graph looks like between x equals -1, but not including -1, and x equals +2, including +2. Now, domain and range. This pretty much explains the domain right here. The lowest x we use is -1, but we really don't use it. The highest value of x we use is +2, and we do use it. Range, the lowest value on this parabola is 0, and it is used because that's where the vertex is. And then the highest value on this parabola is 4, and it is used. The last example goes backwards. Everything we just did, we're going to now do backwards. We're looking at a graph. We see it as somewhat of an absolute value graph, and the parent function of an absolute value graph is y equals absolute value x. But there are some things different about this graph. Its vertex is at -2, -4. So you know that's going to affect the equation. Y equals absolute value. In order for the x coordinate to be -2, this has to be x plus 2. And in order for the y coordinate to be -4, this has to be -4. And we're also missing a slope, because if you notice, the slope is not just up 1 over 1. It's up 1, 2, 3, 1, 2 to hit a point. And then 1, 2, 3, 1, 2 to hit the point. Or you could go 1, 2, 3, 1, 2 and get to that point. But any way you look at it, the slope is 3 over 2. So that would be the equation of this full absolute value graph. F of x equals 3/2 absolute value bar x plus 2 and then -4. However, this is not the full absolute value graph. It's not a V that goes up forever and ever in both directions. It actually has a starting point. It really doesn't have an ending point because it goes on forever this way, but it has a starting point, and that starting point is at x equals -4. and then it just uses the rest of the graph. So y equals, or f of x equals 3 halves, absolute value x plus 2 minus 4 if x is greater than or equal to minus 4.